Let's talk about horizontal tangent lines and what that means with implicit differentiation. It's going to be example number 2. Let's read this together. It says, find the points on the graph of y squared equals x squared minus 2x plus 6, where the tangent line is horizontal. If you remember, a horizontal tangent line means the slope is 0. So we are just going to figure out the derivative of this equation and set it equal to 0. And that will tell us exactly where this tangent line is horizontal. Then next example, we're going to take a look at vertical and how that applies. Whenever this is dealing with a specific wording of a tangent line, you want to translate that into some sort of expression, mathematical. So horizontal tangent line means dy dx equals 0. And so why is that? Well, if you just draw a tangent line that's like that, okay, it has a 0 slope, right? So dy dx would be 0. So just always do that when you're giving wording like this, so you know to set it equal to 0. You'll see that too when we do vertical tangent lines. Step 2, implicitly differentiate. By now you should be very comfortable with all this. It's going to be 2y dy dx equals 2x minus 2. So guess what? Since dy dx is equal to 0, I can just plug in 0 for dy dx. Okay? And then just go ahead and solve for that. You can see this entire left is going to be equal to 0, turn to 0, and it's going to be equal to 2x minus 2. Then you'll just add 2 to both sides. Not sure why I didn't show that step, but I'm going to show it to you right now. All right, and then you get 2x equals 2, x equals 1, right? So what does that mean? Well, that's just an x value, right? You don't know exactly what the y value is, but fortunately, you can plug it back into the original. That's what we're going to do. Plug in y back into the original equation. You get 5 on the right. Make sure I did my math right there. 1 minus 2 plus 6. Okay. And then take the square root of both sides, and you get a plus or minus. This tells us that at x equals 1, there are 2 y values because it's implicit. So at these 2 points right here, the tangent lines are going to be horizontal. 1 comma negative square root of 5 and 1 comma square root of 5. I hope I graphed this for you guys. Let's see, I think I did. But if we round this to decimals, square root of 5 would be 1 negative 2.24 and 1 comma 2.24. This is where we will have horizontal tangents. Yes, I did graph it, thankfully. And here are our points. 1 comma square root of 5, 1 comma negative square root of 5. We will have horizontal tangents on this graph, which is not a function. It does not pass the vertical line test. That's how you do a problem involving horizontal tangents and implicit differentiation. If you have any other questions about it, let me know.